Welcome back. This would be a very brief lecture, not because this is not an important topic. This is perhaps the most mysterious and important um, topic, but this is still not very well understood. But with the understanding we have, we can move on with the course. So we will just briefly describe some aspect of nuclear forces and potential. We are all familiar with gravitational force and potential. So I'm using this word familiar um, because we are familiar that it is familiar to us that gravitational forces are always attractive and they're fairly long range, right? You can feel the force of moon on Earth. Um, just because it is familiar, that means we understand it deeply in the sense that if we ask the question, why is gravity always attractive and is not repulsive? I don't think many of us will not have an answer. Um, but the theory of gravity was unraveled by Einstein. There is a general theory of relativity which provides a rationale for um, these features of gravity. We won't go into this, but just we'll mention that is the way gravity is. Uh, the force which we are most familiar and very consequential are the electrostatic forces. They can be attractive and repulsive, unlike gravity. Both are possible here. They are more short range compared to gravity and much stronger compared to gravity. There's, again, these two we are familiar. Okay, so as we go into uh, the nucleus, um, things become not so familiar. There is also a quantum theory that explains more of the electrodynamical forces. Again, we won't be using these theories um, in this course. So there are weak interactions um, which are important in beta decay, right? So what exactly, why are we using interactions and not as a weak force? That's because um, both these things we can have a formula. Okay, there's a formula here. We know the formula for gravitational force, and we know the formula for electrostatic forces, right? In terms of charges, in terms of masses. Such a functional relationship is not available here, but the interactions are fairly well understood. So the this is also uh, considered to be sufficiently well understood. Okay. Um, then the most important and the strongest of forces are the strong nuclear forces. They are most short range compared to all these things. They hold nucleons together and they are always attractive in the sense that irrespective of the charge of the nucleon, whether it's proton or neutron, the interaction is short range as well as attractive. Neutron, neutron, proton, 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 all these things have attractive, strong nuclear force um, interaction. Um, how it operates, it's not that well understood, but it's not relevant because we will just take one feature of the strong nuclear force and move on in this course. The strong nuclear force is modeled via this potential. This is a model, right? So there is on the y-axis we have potential energy. So there is a deep well, and this above zero. That means here there is attractive potential. Then there is a sudden steep increase, right? So this is why we say strong nuclear force are very short range, and then they become repulsive. So when we talk about a potential, we typically uh, talk about a positive charge, the force felt by a positive charge. So as a positive charge, unit positive charge is brought near the um, nucleus, there is a Coulomb barrier. Okay, so this kind of potential can be either modeled in this manner because this is so deep, anything outside this capital R can be considered as zero. Okay, it's a small number that can be considered approximated to be zero. Then the deep potential is shown here. Okay, so or you can also describe it using this kind of a formula. Okay, these are all models for nuclear potential. So where do we use it? Supposing you're computing something, let's say you're computing scattering intensity. So you need a model for the potential and so on. So we will see the utility of these kinds of model potentials to represent nuclear forces and nuclear potentials. With that, we wrap up the topic. In the next lecture, we will discuss another important feature, that of quantum numbers and nuclear spins. We will take that up in the next lecture. Thank you.